Good morning, everybody. My name is Marlon Pragnell. I'm Vice President of Research and Science at the American Diabetes Association. It's my pleasure to be here today to introduce Dr. James Markman, who is presenting today a very, very exciting research, stem cell derived, fully derived islet cells for type 1 diabetes.
Thank you, Marlon. Good morning, everyone, and thank you for your interest in this work. These are my disclosures. I'll first provide a brief overview of the trial and then show a couple of data slides before discussion. So 2 patients with longstanding type 1 diabetes and absence of endogenous insulin production, impaired awareness of hypoglycemia and severe hypoglycemic events were dosed with half of the target dose of VX-880. VX-880 is a fully differentiated stem cell-derived islet cell replacement therapy. Infusion of VX-880 at half the dose led to successful engraftment of the cells in the liver, demonstrated glucose-regulated increase in fasting and stimulated C-peptide levels, eliminated recurrent severe hypoglycemia, improved glycemic control with improvements in A1C and time in range, and showed reductions in exogenous insulin requirements. Overall, VX-880 safety profile was favorable and generally consistent with the immunosuppressive regimen and being in the perioperative period. Based on the VX-880 safety data and efficacy in Part A, the first patient in Part B received the full target dose of VX-880, and this was well tolerated. So these data establish proof of concept and support further development of VX-880. This shows one of the key data slides for patient 1, demonstrating time and range at baseline and at 2 other intervals, day 121 to 150 and 241 to 270. The latter being the last time the patient has been monitored. As you can see in the baseline readings, the patient had wide glycemic excursions with lots of high values above 250, values below 50, and was in range only about 40% of the time. At the time, he was on 34 units of insulin and had an A1C of 8.6 at baseline. You can see at day 121 to 150 interval, there's marked changes that show a reduction in the very highs and very lows and a much greater time in range of about 80% compared to 40% at baseline. At this interval, the patient was on only 2.6 units of insulin and had an A1C of 6.7. In the final interval, day 241 to 270, the patient had a remarkable 99.9% time in range. And at the time, he was receiving no insulin and had an A1C of 5.2. So really striking results, especially at the last time point. Patient 2 had a qualitatively similar response. At baseline, again, the patient had wide glycemic excursions with many values tested above 250. And also values below 50. This patient had a starting time in range of 35.9% of the time and a daily insulin requirement of about 26 units and a starting A1C of 7.5. You can see at the first interval tested at day 121 to 150, there were similar improvements in elimination of the very high levels and very low levels. Similar, again, qualitatively to the first patient, with a reduction in insulin requirement of 18.2 units at this time and an increased time in range up to 51.9%. The A1C at that time was 7.1. We find these to be very encouraging initial results for this new therapy that we believe has real potential to help many patients. I'm happy to take questions.
We can if there's any questions in the room, I'm happy to hand the mic over. And I just want to make a quick reminder that the information in this presentation is embargoed until 9 a.m. Central Time, just so everyone is aware. And I'll also read questions from online as well.
Hi, Miriam Tucker with Medscape. I understand this study has been put on a clinical hold. What is the status of that right now?
So the team at Vertex is working with the FDA to address the issues that were brought up regarding having enough justification to do the dose escalation. So that's in progress, and we hope that it'll be resolved quickly. And obviously, as soon as that happens, we'll let you know.
Do you know what was the issue?
The issue was just they wanted more information about whether it was appropriate to dose escalate.
I have a question. The 99.9% time in range is truly extraordinary and fascinating to see the data. Can you comment on the immunosuppressive therapy?
Yes. So we agree that the result here was really quite striking. The patient received an immunosuppression regimen that had been developed for the phase 3 clinical islet transplant consortium trials that had finished a couple of years ago. And it consisted of depletion of lymphocytes at induction, and then a maintenance regimen, which with 2 standard agents that we use in kidney transplant patients and others all the time. And that's a regimen that we found to be generally well tolerated.
We have another question.
Hi, Regina Schaefer from Helio and Endocrine Today. Miriam asked the question I was going to ask, but I'll just ask you to expand a little bit. Obviously, immunosuppressive therapy is not for everyone. Can you talk a little bit about the wider implications of this therapy and who might be the best candidates for it?
Yeah, great question. So I think this is part one of a 2-part problem. One is to have a reliable, consistent, effective cell therapy. The second part is to have an approach that doesn't require immunosuppression. So right now, the patients being targeted are patients with very labile disease and severe hypoglycemic unawareness and SHEs. And that's because of risk-benefit considerations. If we had a way to transplant the cells without the need for immunosuppression, then it could be really widely available. And that's one of the great opportunities, hopefully in the future, since these cells can be made in unlimited quantities.
Thank you, Doctor. We have one from online. Is this the first in the world such administration of stem cell derived islet cells to humans?
This is the first in the world administration of stem cell derived islets in this manner, where they're infused into the liver. In the experience with cadaveric islets, the only site that was effective at really gaining full glycemic control was the liver. And so this is the first attempt to really have an important impact on the patient's glycemic control. So I think it's the first in the world at this approach.
I have another question. Beta cell pancreas transplantation has been around for quite some time. And one of the main challenges obviously is that there's such limited supply. But when people do get transplanted, they potentially could be go off insulin, potentially permanently. Can you comment on the supply, how you said this is an unlimited supply? Can you comment more about that?
Yes. So for pancreas transplantation, there are a limited number of donors each year that are suitable. Right now in the US, only about 1,000 pancreas transplants are done a year. And the field has recently contracted, whereas with the other organs, there may be 10,000 or 20,000 transplants done. So the supply for pancreas transplant is a problem. It's also been a problem for cadaveric islets. People have been transplanting cadaveric islets successfully to type 1 diabetic patients, similar to this patients in this trial here. The problem is that the islets from cadaveric donors are variable in quality, and it's also the number of donors available is not enough to supply the demand. So one of the most important aspects of this work is that there can be an unlimited supply of cells for transplantation going forward.
I think we have one more question.
I was going to ask you about timeline. I guess that depends in part on the FDA, but you plan to do a total of 16 patients? And what's the schedule for the dose escalation if presuming the FDA allows you to go ahead?
So it's a three-part trial. Part one was 2 patients dosed with half target dose, and those are the 2 patients that we just described. And despite having half the target dose, both of them had a very good response. The next 5 patients, I believe, are part of the dose escalation, and then there's another cohort that follows with a full dose.
Thank you, Doctor. We have one more from online. Amazing results. Would it be a therapy for very few people, brittle diabetes in high income countries?
We hope that it's a therapy that will be broadly available. Of course, starting out, the patients with the risk benefit that justifies undergoing immunosuppression are the patients that will be transplanted. But again, hopefully someday we won't need immunosuppression, and then it could be much, much more widely available and impact more patients.
Wonderful. We have one more from online. How long are you following the study participants for, and how long do you anticipate the cells escaping destruction from the immune system?
Yeah, that's a great question. So this is a new area and the first time it's been done, so we don't have all those answers. The immunosuppression with the cadaveric islets has been very effective and very well tolerated. So we hope that we can have a durable survival. With cadaveric islets, there are patients that have islets functioning well for 20 years. So we hope this will be the same or potentially better. There's a difference in the cadaveric islets and these stem cell derived islets, I think, in the quality and consistency and reliability. So we might expect a better result using these islets than cadaveric islets.
I want to make sure I'm not missing any questions over here. We have one more question, I believe, unless another one pops up. If the trials keep progressing without any issues, when would a possible cure be available to the public?
That's a great question. Probably not one I can answer specifically, but I think this does bring hope that it's closer than it was before. This is, I think, groundbreaking work and a real leap forward for the field. And so while we can't say exactly when, we know that is closer than it was before we had this approach, I believe.
Sorry, I think we have one more. Oh, here we go. How is patient 1 doing now? Are you still following their progress?
Yeah, of course. Patient 1's doing great. He is probably the most appreciative patient I've ever met. His life was being destroyed by diabetes. He couldn't work. He crashed his motorcycle from Lowe's and really was just tremendously appreciative that he could participate. When I consented him for the transplant and explained that this was a new therapy, there could be unknown problems that we can't predict and that there would be some risk to this. And he said that if I want to participate, if I die from this, if it helps somebody else, I'd be happy, but I can't go on living the way I'm living. So these people really suffer, and this, I think, brings hope to them.
That's great. We have another one here from online. Will there be any trials done on the newly diagnosed?
That's a great question. And I think this is going to be a kind of a stepwise expansion to other populations. And so I don't think there are any current plans for that, but certainly that would be of interest in the future.
Okay, I think that we have answered all the questions. Thank you so much, Doctor.
Great, my pleasure.
Okay, thank you very much.